For thousands of years, the human brain remained one of the greatest mysteries in existence. It controls memory, movement, emotion, intelligence, creativity, and consciousness itself. But now, for the first time in history, humanity may be approaching a future where the brain can directly communicate with machines. At the center of this revolution is Neuralink, a company founded by Elon Musk with an ambitious and controversial goal: connecting the human mind directly to artificial intelligence. Elon Musk has repeatedly warned about the dangers of artificial intelligence becoming more powerful than humans. According to him, if AI continues advancing rapidly while humans remain biologically limited, society could eventually face a dangerous imbalance. Neuralink was created partly as a solution to that fear. Musk believes brain-computer interfaces could allow humans to keep pace with advanced AI. Neuralink works by implanting an advanced brain-computer interface directly into the skull. The device contains ultra-thin threads that connect to neurons inside the brain. These threads are capable of detecting electrical signals generated by neural activity. Once recorded, the signals are translated into digital information that computers can understand. Essentially, Neuralink attempts to create a communication bridge between the human brain and machines. The core Neuralink device is known as the N1 implant. It is designed to sit discreetly inside the human skull while wirelessly communicating with external devices. Unlike earlier experimental brain implants, Neuralink aims to make the technology compact, rechargeable, and minimally invasive. The implant uses tiny, flexible threads thinner than human hair, allowing it to interact with brain tissue more precisely. This level of miniaturization is critical because the brain is extremely delicate, and even small damage can have serious consequences. One of the biggest engineering challenges behind Neuralink is implantation surgery itself. Human hands are not precise enough to safely insert thousands of microscopic threads into the brain without risking damage to blood vessels. To solve this problem, Neuralink developed a specialized surgical robot capable of performing highly accurate implantation procedures. The robot can insert threads with incredible precision while minimizing trauma to surrounding tissue. The threads used by Neuralink are among the most advanced parts of the technology. Each thread is thinner than a human hair and contains multiple electrodes capable of recording neural signals. Traditional brain implants often faced problems because rigid materials damaged brain tissue over time. Neuralink's flexible thread design attempts to reduce this issue while increasing the amount of data that can be collected. Every thought, movement, and sensation in the human body originates from electrical activity inside the brain. Neuralink attempts to capture and decode those signals in real time. If successful, this technology could allow users to control computers, phones, robotic limbs, or even vehicles using thought alone. Early demonstrations have already shown monkeys controlling computer cursors through neural activity. Researchers believe this could eventually restore communication and mobility to people suffering from paralysis or severe neurological injuries. Reading brain signals is only one side of the equation. Neuralink also hopes to eventually send information back into the brain. This concept opens extraordinary possibilities. Scientists believe future brain stimulation systems could potentially restore vision, reduce chronic pain, treat depression, or even repair damaged neurological functions. But this capability also raises major ethical concerns. The medical applications of Neuralink could be revolutionary. The technology may eventually help patients with paralysis regain movement. It could assist blind individuals by restoring visual signals to the brain. Researchers are also exploring treatments for neurological conditions such as Alzheimer's disease, Parkinson's disease, epilepsy, and severe depression. Beyond medicine, some futurists believe brain-computer interfaces could eventually enhance memory, communication speed, and human intelligence itself, creating entirely new forms of interaction between humans and machines. After years of development and animal testing, Neuralink began human trials. This marked a major milestone not only for the company, but for the entire field of brain-computer interfaces. The first human participants represent the beginning of a new technological era where direct brain-machine communication is no longer science fiction. The trials focus heavily on safety, reliability, and the ability to control digital systems using thought. Around the world, scientists, investors, governments, and technology companies are closely watching the results. Initial reports from Neuralink's early human trials generated enormous attention. According to the company, some participants were able to control digital interfaces using only their thoughts. Even simple tasks like moving a cursor or selecting objects demonstrated the enormous potential of brain-computer technology. While the technology remains experimental, these early achievements suggest that direct neural interaction with computers may become increasingly realistic over the coming decades. Neuralink's long-term vision extends far beyond medical treatment. Elon Musk has described a future where humans and artificial intelligence become deeply interconnected. Instead of typing on keyboards or speaking to digital assistants, future systems could potentially allow instant thought-based communication with AI. Supporters argue this could dramatically expand human capabilities. Critics, however, fear such integration could blur the line between human consciousness and machine influence in unpredictable ways. Despite its enormous potential, Neuralink also faces serious risks. The human brain is extraordinarily complex, and long-term effects of implanted devices remain uncertain. Surgical complications, infections, tissue damage, and device malfunction are major concerns. There are also cybersecurity fears. If brain-computer interfaces become connected to digital networks, could they eventually become vulnerable to hacking or surveillance? These concerns highlight how powerful and potentially dangerous this technology could become. As brain-computer technology advances, society may face ethical questions unlike anything in history. Who controls access to neural data? Could thoughts eventually become private information that companies or governments try to monitor? What happens if enhanced humans gain cognitive advantages over others? Philosophers and scientists are already debating whether technologies like Neuralink could fundamentally alter concepts such as privacy, identity, free will, and even human equality itself. Neuralink is not alone in the race to develop brain-computer interfaces. Companies such as Synchron, Precision Neuroscience, and Paradromics are also developing competing technologies. Governments and research institutions around the world are investing heavily in neuroscience and AI integration. The reason is simple. Whoever masters advanced brain-computer interfaces could influence the future of medicine, communication, military technology, artificial intelligence, and even the structure of society itself. Human history has always been shaped by technology, from fire and electricity to computers and the internet. Brain-computer interfaces may represent the next great leap forward. Neuralink's technology could transform healthcare, communication, education, and human capability itself. But it could also introduce risks humanity has never faced before. The future may not simply involve humans using machines. It may involve humans becoming directly connected to them. And if that future arrives, civilization itself could change forever.